Hello everyone, today I'm solving Leetcode question 1584, minimum cost to connect all points. So you are given an array points representing integer coordinates of some points on a 2D plane, where points I equals xi, yi. The cost of connecting 2 points xi, yi and xj, yj is the Manhattan distance between them. The calculation formula is given here. So basically, it's calculate the absolute value of the difference between the corresponding coordinates. Return the minimum cost to make all points connected. All points are connected if there is exactly one simple path between any 2 points, so which means there's no cycle. So let's take a look at the example. So basically, given the 5 points on the plane, the optimal way to connect them in order to get the minimum cost is illustrated here, and then it has the minimum cost of 20. So basically from this example, you can tell that, okay, the 2 points are connected, but there is no cycle formed in this one. So which means, let's say this point 0 is connected to this point, but not any other points on this plane. So that's why no cycle are formed. So that's kind of how the points are connected to each other. So basically, the idea for solving this problem is using Prim's algorithm, or minimum spanning tree. So the idea is, let's choose a starting point, and then we're trying to calculate the distance between the starting point and then all the possible neighbors, and then add the corresponding distance and neighbor points to the mean heap. So what are considered as possible neighbors? So the points that have not been visited. So if the points has already been visited, which means they are connected to some other points, so in order to not form a cycle, we are not consider them as possible neighbors. We keep pop from the heap if haven't visited all the points. So the time complexity for this algorithm, for this idea, is going to be O(n) squared log n. So basically n is the number of points. So, and then since we are utilizing a heap, so I'm going to illustrate a little bit more about this idea, how this algorithm works. Let's say we have 4 points represented by index 0, 1, 2, 3, and let's choose the starting point. We start from index 0, and then that's corresponds to point 0. So the heap starts with our starting point, and then the distance between the starting point and itself is just 0, and then the starting point is 0. So in the first iteration, we pop this one from the heap, and then we look at all the possible neighbors. So currently, only this point 0 has been visited. All the possible neighbors are 1, 2, 3. So we calculate the distance between them, and then add them to the heap. So basically, after popping the point 0 from the heap, we add the point 1, 2, 3, and then the corresponding distance between point 0 and point 1, 2, 3 into the heap. And then now we are looking at the heap. This time the heap contains those 3 elements. So we are trying to select one to pop. So remember, we keep a mean heap, so it pops based on the minimum distance. So in this iteration, let's suppose our minimum distance is between point 0 and point 2. So we pop this one from the heap. So now the heap has 2 elements remain. And then we have the point 0 connected to point 2. And then now since we pop out the point 2, we check all the neighbors to point 2. So all the possible neighbors are point 1 and point 3 because point 0 has been already visited. So 0 and 2 are connected to each other. So in that case, we add the distance between point 2 and 1, point 2 and point 3, and then to the corresponding point 1 and point 3 to the heap. So now what's in the heap? So basically it's this line 19, line 21, line 23, line 24. So that's the status of the heap after we pop out the point 2. So now we pop another element from the heap. So I utilize the number 3 to indicate, okay, that's the 3rd element being popped from the heap. So let's assume in this case, the distance between 0 and 3 is the smallest in the heap. So we pop this one. Now we visit the point 3, and we are trying to look at all the possible neighbors for point 3. So here point 0, point 2 has already been connected. So point 1 has not been connected yet. So that's the only possible neighbors. So we add that to the heap. And now we look at the heap and then we try to do another pop. So that's kind of how the algorithm works. So let's start coding. So let's code the distance calculation. So basically we are calculating the distance given 2 points. We want to return the Manhattan distance. So just follow the formula listed in the problem statement. So in this case, let's utilize a variable total distance to represent the distance or the cost to connect the points. And then initialize our heap. So we choose the starting point. We just choose the first element in the points as the starting point. And then we utilize a set to keep track of all the points that has already been visited. So remember, we don't want to form the cycle. So if our point has already been visited and then connected, so we do not want to repeatedly visit them. So let's try. So basically, when the length of visited is not n yet, so which means we still have points that we haven't connected yet. So we just keep pop from the heap. If you visited. If this point is not visited, then we check all the neighbors. We first visited, add it to visit, and then we add it to the distance. And then we check all the neighbors. Okay, so we forgot to assign the value to variable n. So n equals the length of points. If this neighbor is not itself and this neighbor not visited, in that case, we push that to the heap. Heap push. So basically, we calculate the distance between the point and its neighbor. And then also add this neighbor points to the heap. After we connect all the endpoints, we just return the total distance. So this is our solution.